Good afternoon, everybody. We're thrilled to have you at the last session here at the Java 1. I must start with making an apology to all of you, because in this session there won't be any Java code. Sorry for that. Yeah. But to compensate that, we have some Groovy code and some Sparkle. So I hope that that helps. My name is Hans Gringhuis. I'm a fellow at Lucene. Almost 20 years in the IT business right now. Next to me is Mark Teutlink, also a very experienced IT architect, also working at Lucene. This talk is going about enterprise search. Enterprise search is not about searching enterprises, but it's all about finding information. It is a very broad subject. And we had a lot of thought about how to address all these subjects. What we saw is that one of the biggest subjects of this Java 1 is modularity. Modularity is a very old, I think from the 70s concept. So we thought, okay, it's cool to bring back old stuff nowadays. So we're going to use the 4+1 view. It's a very, very known way of describing architectures for addressing all the issues concerning enterprise search. We made a slight modification to the 4+1 view. It's called the 5+1 view because we need an extra view. Let me first try to explain what the 4+1 view is. As I said just as that enterprise search has a lot of different aspects, like architecture, which has also a lot of different aspects. So what we're going to do is give this talk and address the issues by using the views of the 4+1 view. And we start with the logical view. What you do in the logical view is that you describe the decomposition of your system in logical abstractions. For example, if you're having an object-oriented system, your logical view will encompass the object model of your system. The next view we're going to use in our talk is the process view. The process view is all about processes, threads, concurrency, and has a lot of impact on the scalability of your system, which is of course very important in enterprise search. Then we're going to talk about the physical layout of a typical enterprise search application in your development environment, which technologies are used, which libraries are used, and how they put together to form the solution. Once you have the software, you have to deploy it somewhere in your infrastructure, and the mapping of the software solution to the infrastructure is what is described in the deployment view. And of course, an enterprise solution is a solution for users. So all the user cares about is the functionality, which is offered by him, and the functionality is described in the use case view. And if you look at if you look at an enterprise search solution, a key component, a key aspect, of course, is content, is the information. And that's why we've added another view for the 4+1 view. We call it the information view, just to describe the information aspects of the solution. It's all about metadata, structure, content structure, and how it is related to each other. During this talk, I'm going to describe for you the use case view and the information view, which are the boring aspects of this talk. Then we'll go into the real solution, and Mark will take over and describe how an enterprise search solution is built. So from a functional perspective of what is enterprise search, and I had to answer this question a lot of times, because if you're talking about enterprise search, the first question we always get is, what makes it different from Google search? because we all know and love Google or Bing, but I think most of us know Google. And part of a search solution is not searching, but finding information. So what you see over here is a typical UI for an enterprise search solution. And it has Google-like results. It's what you see in the bottom left. It's the results of a query. They are ordered. Small description of what is found, and you can click on that, and then you go to the document which is found in the result set. So nothing new. But there are some other pieces of information on the screen. That is the grouping. What you see over there are facets, and it is a grouping of the results found based on the search query you have done, and it is domain specific. So what you typically can do in an enterprise search application is that you have a model of the information, and you can group the results into specific clusters of information, which can be defined by yourself. Another aspect of enterprise search is sorting, because if you have a large result set, you want to influence the ranking of the results you have found. Sometimes, let me give an example. If I'm looking for Java, for example, I can get a lot of results. And sometimes I want to sort them on date of publication. Sometimes I want to sort them on author. Another way to sort them is the subjects which are treated in there. So having a domain-specific sort functionality is also which is very important in enterprise search. And then, of course, the last thing is filtering. Sometimes you want to exclude, and also based on the domain definition you want to exclude results from your query. So what makes enterprise search different from Google is that you can add your own domain knowledge, your own knowledge about the information to the search engine, and use that information in providing the user with better results. That's the whole meaning. But that's not the only thing what distinguishes enterprise search from Google search. What you see over here is a typical layout of all the information which is present in an enterprise. So what we have here is web pages, but also behind the firewall we have enterprise content management systems. We have a lot of databases with useful information in it. We all know the famous directory structure where all the departmental documents are located. And if you look at Google search, it can only index, it can only search for the internet public addressable information. But from an enterprise search perspective, there's a lot more interesting information available in your enterprise, and that should be found by the enterprise search solution. Let me recap. So enterprise search is all about finding the relevant information of all the documents in your enterprise, where a document is a very broad term. It isn't just the Word documents, there's also PDF files, databases, content management systems, fast and good, and having good results. where it's also very important that it is integrated within the security system of your enterprise, because it's only the results that you're authorized for to see should be shown to the public. This is, from a functional perspective, the biggest difference between Google Search and between Enterprise Search. Okay. Now I want to shift from the functional perspective to the information perspective. And as I just said, is that what we want to do with Enterprise Search is that we add domain-specific knowledge to your documents. So, very important in an Enterprise Search solution is that we have knowledge about the context in which the information is created, used, and searched. So, what we do in an Enterprise Search solution is that, if we look at this picture, is that all the information is indexed. Our solution is based on the Lucene Solr, so all the information is in the Lucene Solr index. But before it is placed into this index, it is enriched. What we do is that we add domain-specific knowledge to the document. If you mention knowledge, you need some way to model that knowledge. Modeling knowledge can be done in several ways. We're using semantic technology for that, so you can describe your knowledge in RDF, but you can also use other forms of knowledge modeling. So what we do is before we index the document, it will pass our knowledge repository, and there it will be enriched. Let me give an example. If we encounter Java in a document, we can add metadata to the document about Java. But what is Java? Is it an island, or is it a programming knowledge, in a programming language? It can be very difficult to decide which of these two it is, but because we know the context in which the document is created, we know, for example, the author, or we know the company where it is made, it is very easy for us to judge whether it is a programming language or it is an island. So by applying this domain-specific knowledge, we get better metadata about the document, which we can use in our search queries. On the other side, what we can do is, if there is a search placed within the search solution, we can also use the same knowledge for enriching the search request. So if you're looking in your search query for Java, we can add programming language, imperative language to the search query, and we can return documents with no Java but imperative programming language, which you should also find in the return set. And the last thing we can do about providing better search results is that if a user is logged into the system, we have a profile of the user, so we know the interests, we know the department he's working for, the projects he or she is working for, and we can use that information while creating the search request.
Question?
Yeah.
Should I wait till the end?
Yeah, it's okay. It's okay.
So you basically build on Solr and Lucene.
That's correct.
Add your domain-specific knowledge into the index. Is that correct so far?
Yes.
Into the index, if you look at the indexing stage, but we also add it at querying time. So if you fire a query to Lucene Solr, we can enhance the query before it is sent to Lucene Solr.
And what kind of metrics do you have that the results are X amount better, or Just
Mhm.
trying to understand the difference between what you have and what's kind of out of the box from Solr.
We'll come to that later on.
Mark will address that.
Yep.
It's a very good question, but it will be addressed later in the presentation. It's okay?
All right.
Yeah. Okay. Okay. I'm going to hand off to Mark.
Okay, thanks. Yeah, it's on. Hans told everybody about the use case of the system, about the information view, and now it's time to see how we turn it all into software constructs. So I'm going to talk a little bit about the logical view. And in order to do that, I'm going back to the information view from Hans, where we have on the left side the web pages. This is an example. It could be more sources as well. That is going to be indexed inside the enterprise system, and that part is what we call the collection process. On the other side of the equation, we have something called the publication process. If you have something inside the index, then you can search through it, and that's what we call the publication process. So there are two different processes that we're going to address. With this in the back of our minds, this is the logical architecture that we are using. On the left side, you do see the collection process, and on the right side, there is the publication process. So let's go through all the components from the collection process first. It all starts with sources. You know, in an enterprise search system, we don't have any limitation on sources. They could actually be anywhere. Behind a firewall, in a database, in a semantic store, in a content repository, web pages, whatever, you know, they can be anywhere. And it can also be in any format. It can be a Word document, it can be a PDF, it can be a Keynote document, but it can also be, you know, a text, an unstructured or a binary document like a video or an audio file. There is also metadata inside an audio file as well. And last, you know, it can be a compound document. It can be a zip file containing other formats as well. And we all have to cope with that. And the other thing is that, you know, just like Hans said in the picture, that the internet addressable stuff, you know, we'll have to cope with security as well. Sometimes documents are behind a firewall or behind any security boundary, and that we'll have to handle that as well. So from all the sources, how do we actually get information from sources? There are actually three ways to get them. First is what we all know from Google, you know, the crawling, the spidering, and that's where we unleash a robot on a, for example, an intranet or something, and they will crawl through all the documents, you know, traversing all the associations to other documents, and on its path, taking all the documents with it, and then at the end, we have all the documents from a complete website or a complete directory structure whatsoever. That's what we call crawling. The other thing is what we call harvesting, and harvesting is actually periodically pulling out of, for example, a content repository or a database or whatever. It's still a pull system, but it's not crawling. The last thing that we see over here is push. We have to cope with, you know, with companies or third parties that do have information for us that is very relevant for us, and they're going to be able to push them into our system. So we are going to give them APIs to do that. Now you can think about, you know, SOAP web services, REST services, or even Java APIs. We have all the information. If we have them downloaded, if we retrieve the information, we have to validate whether the information is correct. So we have to look at the documents, and we have to see whether they are syntactically correct, whether the structure of the document is what we expect it to be. And on the other side, we also have to look at the content itself. We have to validate the content from a semantic point of view. You know, we got some metadata properties from a document, but the combination of the metadata properties, are they valid? You know, an example could be a zip code and a house number. You know, if you have a zip code and a house number, we'll have to check whether on that zip code, that house number does actually exist for a certain property, and if it doesn't, you know, the document is invalid, and we'll better not index that as well. So, very important for a validation point of view is what do we do with the documents that we actually reject. So it's very important that we either bring them back to the redaction or the editors from the original document or any third party whatsoever, so that they can actually take action on all the things that we found. When the documents are valid, and then we are going to enrich them. We are going to add information to it, which we call enhancing. So if we have a set of metadata properties, we are able to actually add metadata properties, for example, based on third-party knowledge repositories inside either a semantic repository or a database or an XML document or an XML database whatsoever. But before that, we do get a set of properties. But sometimes, there are many more properties inside the document, and that's also an enrichment step. It's called extraction. So, for example, if you get an HTML document, or then you can actually use XPath, for example, just to extract even more metadata from the document. And then the third enrichment is what we call filtering. It's actually either taking out properties that we think are not relevant or will clutter all the information, or it's actually, for example, if you have a web page, there's all kinds of information on the web page that are definitely not relevant for searching. For example, the navigation part of the document or the ads, we just want to filter. We just want to take them out, and we only want to have the relevant pieces of the documents, so that we have better search results. When we have all the documents, we have validated the documents, we have enriched the documents, we're going to index the documents. In other words, we're going to send them to the search engine, and the search engine will actually analyze all the documents for us, and it will make them searchable. And they're storing it in a searchable format inside an index. And also at that point of view, we are able to tell them this is a more important document than another. So we can actually already do some boosting there as well. When all the documents have been indexed inside the indexes from the search engine, we can actually go and try to find whatever we want to find inside the index. So we are going to actually send in a search request into the search engine, and we get search results back. So the first component inside that publication process is how do we actually issue search requests? Well, actually, there are many ways to issue search requests. And so it can be a GET interface, HTTP GET interface. It can be a POST interface like a web service or a REST service. It can be APIs from all kinds of stuff. There are hundreds of ways to issue your search request. When we've issued a search request, we have to check whether the search request is valid. Coming back to the zip code and house number, if we have a search request where we explicitly want to find information for a certain zip code and a certain house number, we better check whether that combination is still valid. And if that combination is not valid, we're going to be sure that no documents whatsoever are going to be found. So in that case, we have to check whether not only are the search requests coming in with the proper structure, we also have to check them and validate them semantically. And there's the other step that we find very important. It's if we have a search request and we know the person that is issuing the search request, we know the context of the search request, we can actually enrich the search request. We can actually look at the several clauses from the search query, and we're going to recommend, for example, you misspelled your filter, or no, it's you trying to find the term San Francisco inside a free text document, but you know what? We do have explicit properties called city. Do you want to search on city San Francisco instead? Because that would actually be result into better search results. And we could also do that under the hood. So if we haven't stored zip codes inside a document inside the search engine, we can actually, in the enrichment phase, we can actually look at the zip code, we can turn it into a coordinate, and then we can use geospatial search as well. And we can all do that under the hood in the enrichment part. when we have a proper search request, we are going to unleash it on the search engine. We're going to tell the search engine, go and filter all the documents out, filter all that is not relevant based upon the search request. So it's going to look at the entire set of all the records inside the search engine, and it's going to take out all the non-relevant, leaving at the end a smaller set of search results. And from that smaller set of search results, we can actually apply grouping to it. So we can say, look, from a domain-specific content, try to tell me how the explicit set of results are being grouped. So how many, let's say we have 1,000 results, how many of them do apply to the city of Los Angeles? How many do apply to the city of San Francisco? How many do apply to the city of Amsterdam? If we have that and we can hand over the information to the interactive user, for example, he can make a better choice. He can look at that grouping and say, okay, oh yeah, I want only the documents from that specific group. And the other thing is that sorting. We have to apply specific ranking, where Google is only capable of ranking on either date or very smaller parts of the document. We can actually rank on anything. We can rank on specific metadata properties. We can rank on domain-specific metadata properties. We can actually use domain-specific repositories to calculate new ranking algorithms. So we can actually be more specific in ranking. All the search results coming out of the search engine, we are able to look at the search results, and we are able to actually tell them, okay, these are the search results, but based upon the search results, we think that the other search results might be also of your interest, or there are more documents that might fit your search query. So that's also a recommendation redirection based upon the results. And the other side was do a recommendation based upon the request. And the other thing is that we use that enrichment step as well, just to add extra information. Normally you get some properties that are indexed, but we can actually go out and put more information in there as well from other other outside repositories. And we can even put in editorial information. For example, if you get results and it's almost the end of the year, we can even put in an editorial comment saying, oh, by the way, it's the end of the year, you hadn't filed in your IRS, for the IRS, you hadn't filed in your tax return statement, whatever. We can also put that in if we want, if that is relevant as well. The last step of that equation is that when we have all the results, we have to be able to present them to the user that is using the system. And that is where we actually differ from Google search as well, where Google is more about selling ads, and it's trying to have very minimalistic, generalistic search result screens, with a lot of ads there. We can actually make very rich user interfaces, making possible for the users to find the information even more quickly. So it's all about finding information. Yeah?
Are you using for your geospatial injection a geohash or something custom?
I have an example of that later on. We actually use a component inside Lucene Solr to do geospatial search. And we are using Google Maps API, and that's the example, to actually take the zip code out, turn it into a coordinate, and then also index the coordinates as well. But there's an example in that. That's the Groovy code that we're talking about. What we noticed from the logical view is that there's a lot of enrichment and validation everywhere inside the logical architecture. And we would like to reuse a lot of that. So we would like to make components, enrichment components that we can reuse in the collection process, but also in the various publication processes as well, and also across multiple tenants. So we said, okay, we have to think about the logical view of an Enricher component. And looking at the Enricher component, we found that it's actually following a pipe and filter architecture. So actually we are going to feed the documents into a flow, and it's going to execute actions on the documents, and the outcome of the action is going to be put back into the documents. It's going to do another action, and the outcome of the action is going to be put back into the document. So it's actually traversing a certain flow, and in that flow it's actually doing enrichment actions. Extracting, filtering, enhancing, but even validating is also part of that. And what you see here, for example, is it's a very easy example. Document coming in with 3 fields. You can remove a field. You can look at the field, and then based upon the contents of the field, go either this way or that way during the enrichment. That's content-based routing as well. So looking at from that point of view.
There's a question.
Oh, sorry.
Could you
Yeah.
can you specify your domain in the search term?
Sorry.
Specify your domain in the search term.
We could. The enricher, what we did create, is an XML-based domain-specific language where we actually specify domain-specific enrichment actions. So if a search request coming in, we can use an XML-based language to turn the search request into a domain-specific search request. And there's some example of that later on.
Would you present that ability to the user so if they knew how to do it, they could present their own search term with exactly which domain they wanted?
What we normally do is that the configuration of that is being done by the company, by the enterprise,
Yeah.
and we are not actually.
Search engines that think they know what I'm after trying to.
Well, it's not the search engine; it's the people that are configuring the enrichment actions. But you can choose whether you're doing a filter or a ranking. So there's a lot of choices there that you can do. But the choices are all up to the enterprises that are behind the search solution. We can talk about that later on. Maybe it's going to be answered by some of the examples that we have. So again, what we did is that we build an XML-based domain-specific language just to orchestrate the flow of the enricher. And inside there we can do if then else, switch case else. We can add, remove fields. We can execute expressions, enrichment actions, and we actually already built some enrichers that we can use inside the flows. One of them being HTTP client, where we can actually extract information from a URL based upon a URL. If it's REST, what's coming back, we can use OGNL just to parse the REST and then to extract metadata from the REST response. We can use XSLT, XPart, XQuery to go to XML-based repositories and extract information of that. We can use JDBC. We can use Sparkle. There's Sparkle here, which is a query language for the semantic repositories. And we can also go out to another search engine, for example, and just to do another search request, and the response of that search request being fed into the original document as well. And the last thing is what we can do is Apache Tika. And Apache Tika is a library for extracting metadata, from a huge amount of different document types. It's pretty good. There's an example of the XML-based domain-specific language that we have. What you see over here is an enricher, and the enricher goes from top to bottom. It adds a field A, it adds a field B, it adds a field, another field B, and there is adding something with this. It's a velocity replacement where we replace the A between brackets with the actual content of A. So we're going to create new fields with the content of the other fields. And there's an if then else add field. We can remove fields. That's the basic part of it. But it can also be a little bit more difficult than that. For example, we can add a field, we can add a property called URL. We can use an HTTP enricher, to grab the contents behind the URL, put it inside the website property, and then we can use an XPath expression, for example, just to get the H1 element to create a new property called title. We can actually filter the website by taking out all the things that are either relevant or not relevant, making a new property called filtered website. And then we can use tika just to take out all the individual terms from that filtered website. And then later on we can actually use switch test just to look at the various fields to create new pattern, new properties. So it's a very powerful but also a complex DSL that you can actually use in all the parts within the architecture, as well in the collection process, as well as also in the publication process and the request side, but also in the response side. So you can use this, for example, to enrich your search request. There is an example of the use of Sparkle, just creating a field called place, and then executing a Sparkle statement on a certain Sparkle semantic repository. Using the information from another property that we already have, and the outcome of this Sparkle query is also going to be inserted into the document as well. And this is the code that we have for the geospatial search. So that might be your answer to it. This is a very funny thing. What we do over here. Let's see whether this works. You can see this? Okay. We have a field called fq.location zip code. FQ stands for filtered query, which is a construct inside Lucene Solr. What we do is that all the individual classes of a search request will be individual properties inside the document. So we are actually saying a search request is also a document. And then if we know that it's a document with fields, with properties, then we can also enrich it. So we can actually do all the enricher things with it. And that's what we did. So we're looking at the filtered query class. If it complies to a certain pattern, regular expression pattern, then we know it's a valid zip code. And if we know it's a valid zip code, we can actually execute some groovy code, scripting code, and then the outcome of this scripting code, it's actually going to call a Google Maps API, and the outcome of that scripting code is going to be put back into the document, or in this case, the search request as well, which means that your search request is not going to be enriched with the coordinates that you get back from the Google Maps API. So instead of searching on a zip code, you're going to search on a coordinate. And if the pattern of the zip code, it doesn't comply to the regular expression pattern, let's go back to. I push the button. If it doesn't comply to the regular expression over here, we're going to reject the document. In this case, we're going to reject the search query. So this is a very declarative way of enriching your documents for the collection process, your search request, but also your search responses. And you don't actually need to code anything. It's just a declarative way to do that. Let's go to the process view of the solution that we do have. Let's look at the collection process first. From a collection process point of view, what we did just to make the system more responsive, we actually split up the collection process and the publication process, which looks very logically to certain people, but then again, it's very important to do that. The collection process, all the information coming out of the collection process is going to be indexed into Lucene Solr, but it can also be on a very different machine. And then on another machine, the publication process is going to use the indexes, and that's where we split up the collection process and the publication process. What we also looked at is that, from a collection process point of view, we noticed that not only enrichment is a flow, but the entire process of the collection process is a business process flow. and a business process flow, in our opinions, we are looking towards a concept of an enterprise service bus in this situation. And why do we choose to use an enterprise service bus for the collection process? Well, it's very simple. All the concepts within the ESB actually map perfectly on the business process that we do have. So we can actually use channels and pipes just to get decoupling between the different services, between the different components of the collection process, so that we can actually have we can actually make the entire collection process asynchronously. So if we finish the content inbound, we can asynchronously validate it, asynchronously enrich it, and that will speed up the things as well. So it's good for performance and scalability as well. We can also make it parallel, so we can actually do the content enrichment in parallel a lot. So that will actually speed up the entire thing as well. Content-based routing is also very important. If we have split up all the components, we could use content-based routing that looks inside the documents. We can use it to map, to route the information to different components and even to different machines, different nodes in your cluster as well, which makes it more distributed and scalable as well. You get all the things like hot deploy. We can split it up in services, getting more modularity. We can do reuse of all the components over more than one collection process so different collection processes for other customers. It does fit perfectly. And the good part of that, using an ESB, you get all the nifty things that you normally would have to program. You get them out of the box. So you get all the components like the transformers, the validations, the splitters and the filters, the routers, everything, it's out of the box. It's there inside an enterprise service bus. And from a content inbound point of view, enterprise service buses do have a lot of transports available already. So web services, SMTP, JMS, sometimes JCR, everything is there. So all the tools that we need, to get the information out of the sources is there and to be leveraged. So it does have a very good fit there. What I'm trying to do in this picture is that the collection process, and I'm going to express it using an enterprise integration pattern kind of way. So what you see, this is not going to work. What you see over here is that the components from the logical architecture, we created services from them. So this is the content inbound service. We have a validation service, an enrichment service, an indexer service, and they all are decoupled by channels, which means that they can all run asynchronously in parallel on different machines, distributed. So this really helped us getting a very responsive, scalable collection process. From an implementation point of view, let's look at what components did we use to do the implementation of the several components within the logical architecture. Going back to the logical architecture, what you see over here, let's put something on top of that. Now we use Apache Lucene Solr for the search engine and for the index. We used on the left side, we use a tool called Apache Nudge to do the crawling, the spidering thing, and Apache Nudge is an Apache Hadoop-based crawling utility, which is very scalable, very performant, works perfectly. And we're using Apache Tika to do part of the extraction of documents that we normally can't do that, like a Word document or any, the .doc documents or the .pdf documents. You have to do a lot of things there, and Apache Tika can do it for us. And the entire collection process, we are using an enterprise service bus. In this situation, we have used Mule ESB, but Apache Camel works as well and might be a better solution, a better solution in other situations. From a UI point of view, you get the results back from Solr, and it doesn't really matter what kind of tools you use there. And so we have used all kinds of tools. We have even used PHP with Smarty templates. We have used Groovy Grails just to create the presentation. We have used all kinds of tools here. From an enricher point of view, the enricher that we talked about with the XML-based DSS, we actually build our own enricher framework. And that enricher framework is going to be talked about later on, what we used over there. Going back to the publication process, what we said is that we have leveraged a tool called Apache Lucene Solr, which is a very, very scalable, fast, full-text search engine, completely written in Java. It has a lot of function and features that we can already leverage out of the box. So there's hit highlighting, there's faceted search, which is grouping, and it has caching, it has boosting functionality. It is very good in scaling, distributed replication of indexes. So there's a lot of things that is there already out of the box. And it's open source, and the good thing, it is very, very extensible. They really gave a good thought about how we are going to split up the entire Solr solution into good APIs, good modular systems. So that's what we leverage very well. So the thing is, what we did with the publication process, we just embraced it. We said, come on, it's you know, building your own search engine doesn't make sense. You know, just pick one, and this is the best search engine, open source Java-based search engine around. So we could actually use the synonym handling, the stop words, you know, the stemming, the more like this, the spelling for set. There's a huge amount of functionality that we can already leverage out of the box, and we did leverage that out of the box. Of course we did. You know, from an API point of view, it already had a huge amount of APIs that we can use. You know, it has JSON APIs, it has XML APIs, PHP, Java APIs. There's a lot that you can actually leverage. So why do it over again? You know, reinvent the wheel. That doesn't really make sense. From a customization point of view, for each enterprise that we had to, you know, tune it to the enterprise itself, tune it to the tenant itself. So we have to create a specific schema for that specific enterprise. And we have to do some configuration of the runtime of Solr for that specific enterprise. But, you know, and the other thing is that there's a lot of enrichment already inside the Solr stack, but we wanted to get our enricher, you know, where we can actually leverage and reuse all the enricher actions that we have, and the XML-based DSL. We had to extend Solr so that we can actually use that for enriching search requests, but also enriching the search responses. Another thing that we did add was a little bit about security, because, you know, if you are in an enterprise and you have indexed all the information, it's not said that everybody within the enterprise has access to that information. No, it could be that a certain, you know, that the director has more access to other documents than someone on the working floor. So we had to extend the Solr system with security features as well. Coming back to the enrichment framework that we have, you know, looking at from a point of view, we already see it's a pipe and filter architecture. Enrichers, you know, they are traversing a certain flow, doing all kinds of enricher actions in a certain order. So it's extracting and enhancing, filtering, validation, and we tried to find a modular way of doing that. So what we did is that we used OSGI to build enrichers. And we made it capable of plugging in OSGI bundles inside the enricher framework so that it immediately is extended with new enrichers. So from a point, I'm going back later on why that is so important as well. And then from a orchestration of a flow, we have actually built an engine based using SEX event handlers to handle the domain specific language and to actually call the enricher bundles as well. And using OSGI gave us a lot. It was hot pluggable, it was updatable, it was modular. We could actually reuse enrichers, and we didn't need to restart the entire system when we made changes to all the enrichers, and even made changes to the configuration of that. And it's very, very extensible, which means new enrichers, just create a new bundle and just install it inside the OSGI container, and you can use it immediately without restart, without downtime, anything. And if you're looking at from a deployment point of view, which comes back later on as well, but from a deployment point of view, using OSGI, and we have a tool called Apache Ace, we could actually, deploy or we could actually, what's that called? Provision the bundles, the enrichers, and we could provision also the configuration of the flow, but also the configuration of the schema of Lucene, and the configuration of the collection process, the Mule, the ESB flows. We could provision the configuration using a tool called Apache Ace over many of the nodes within the cluster if you're deploying it on a cluster as well. So the last thing I want to talk about is deployment. Of course, if you have a system and you're going to use it inside an enterprise, it gets bigger, which means that at a certain moment in time, you have to think about clustering, adding more nodes just to get more scalability, just to get more performance. And if you are able, with the content-based routing and the collection process to distribute the components on different nodes, you have to think about that. So let's take a look at one of our typical ways of deployment. What we did is that from a collection server, we took one big server to do all the collection process work, and we stored them in indexes from Solr, and we had a couple of we called them slave, a couple of publication process servers, and we could just add more of that. And there's a load balancer on top of that, and looking from the left side, all the deployment, so all the new changes to the search solution, which are we could all provision them as bundles because we have leverage. We have embraced OSGI as well, so that works pretty well. It's very flexible, which means that if you want to have more collection process servers, we just add more collection process servers, and they all work together. And on the other side, so Lucene Solr is very good at, for example, index replication and making a cluster of search engines. So we can just add more search engines to it, immediately getting more scalability and more performance. So that works pretty well as well. So what we talked about now is we talked about the search engine. We talked about how we how we implemented the collection process. We talked about how we implemented the publication process. We talked about the enrichment functionality, the enrichers that we have, and what we did to make that possible. How we deployed it, and that actually concludes the presentation. There's some more to read for that. The solution that we created, so the entire collection process and the entire publication process and the enricher and all of that has been given to the Amdatu guys. And just take a look at amdatu.org, which is a pretty good framework for building very rapid cloud-based applications, OSGI-based more or less. So all the solutions that we build, they're all part of the Amdatu stack. Some more read about the search engine. There's, just check out the Lucene Solr webpage. It's pretty good. And the last part to read is about a company that we all work for. It's called Luminous. Just check it out. So this does conclude the presentation. If you have any questions, just let me know. Yeah. The question is whether we have implemented field level security. Yes, we did for a customer. Yes, we did. And we did that by adding a specific field where we have added, the ACL stuff. We just add it in that field, and then based upon the profile of the user that is logged in, or we could actually extend the filters using the enrichers. We could extend the filters under the hood with giving them with adding more security-based filters to the search request. That is how we did that. Yes, it is. The question was whether it's late binding. It is late binding. It's done at runtime.
What about scenarios where we do not know about attributes ahead of time? So like a lot of dynamic attributes still need to be part of your index.
Yes.
So the bunch of the configuration that we would otherwise find is possible to do. So do you support the scenario where we have to support a lot of dynamic attributes in the course?
It is. The question is whether we support the addition of dynamic attributes where we don't know the attributes up front. That's the question, right? So yes, we actually do. Normally, what happens, for example, if we use Apache Tika, with Apache Tika, you can just extract all the properties that it can find, which might be properties that you don't know about. So we use that as well. Is that an answer to your question?
The way I'm trying to figure this out is, say, going forward, like we keep adding more and more attributes
Yes.
as business grows. What I'm saying is, but this whole pipe is already implemented.
Okay, the question is, what do we do when you get more properties on the way? When you have it in production, the configuration of the pipe is XML. And the XML can be provisioned by the Apache A stuff. And as soon as it is provisioned and it is stored on the servers, it will actually use the server, the Enricher framework will use that XML. So you can do that when in production, which sometimes might not be a good idea, but you could.
Pretty much everything can be, all the attributes aspect of it, variable aspect of it is all controlled only through configuration.
The question is whether all the attributes of the enricher in this situation, in this case, is controlled by the configuration, by the XML-based configuration. Yes, there is more. For example, a Lucene Solr, and if you use all the features part of Lucene Solr, then a restart might be needed sometimes. But from a enrichment framework point of view, there's no restart necessary.
How does it handle, or I don't know, does multilingual documents in the same index? Can you do that?
The question is, how do we handle multilingual documents
In the same index.
in the same index? If they have a different key or URL, then there's no problem whatsoever. So
more along the lines of like they're going to have different sets of stop words.
okay,
Different
that's what.
stemming rules.
Okay, now I understand. When you look at the enricher, the normal solution in Solr would be a text file with stop words, with synonyms and stuff like that. But looking at an enrichment framework, you see that we can actually go into a semantic storage. We can go into a semantic repository, and that's what we also did. We have some ASCOS libraries, for example, stored outside of the publication server, and based upon the search request coming in, we can actually do a specific Sparkle query, which can be language specific. So we could actually, based upon the language in the search request, we can actually add other synonyms than the ones in the text file. And ASCOS is really good at defining synonyms and broader and narrower terms and stuff like that.
I was thinking more along the lines of the actual process of on ingest, when you essentially boil everything down and you apply those rules to what's coming in.
Mm-hmm.
If you have multiple sets of rules, right, you know, for each different language,
It could be.
it's not going to necessarily boil things down correctly if it's all in one index.
We could, looking at the Enricher framework,
Yeah.
there is a way to do content-based routing towards different indexes.
So you would need separate indexes.
You could.
Okay.
You could.
And then,
But you could store it as well as a different document as well inside the same index with other properties.
okay.
That's possible.
If you have separate indexes, how do you rejoin the results?
If there are separate, Solr has functionality just to do some, it's federated search, you know, searching through two indexes and then combining the results. But I already also did a project where we did federated search on more search engines, not only Solr, and that's where we used an ESB as well. You could do that as well. More questions?
So just mentioned when you search several search engines, were you able to integrate the search results, or did you then simply return 3 lists of search results?
Okay.
Because of the different relevance.
Yes. Yes. The question was, using federated search functionality, were we able to combine the results coming back from the different search engines into the yeah, that's the hardest thing in federated search, because they have different architectures, they have different relevant algorithms. So you know, so there's also a trade-off there as well, and it's not only the relevance, but it's also the you know the how fast are the results coming back? Are you going to be waiting for all the search engines, or are you just going to be make it asynchronous and then put a listener there to get all the results back, and then as the results coming in, then adjust using Ajax functionality, adjust the UI like that. Federated search is really interesting technology. Let's call it that way. But it's extremely hard, especially the relevancy. So there has to be, because we have the enrichers. What we did is we try to we try to map the different relevance scores, the different scores coming back, because they're just metadata properties. We try to map them on a generic relevance. Yeah, we try to normalize them as well, which worked pretty well, but it's still difficult.
How can you handle some complex queries like this max or posting stuff in this solves that factor?
Okay, the question is how do we handle complex things within the Solr stack, the dismax handler, stuff like that. Most of it is not done via the enricher, so we're leveraging the standard stuff from Solr there. Is that your question answer?
Yes.
Yeah, we just, we embraced Solr. The only thing that we did with Solr is that we use its extensibility, way of extensibility to add plugins on the request side, and also have a plugin on the response side, and through that plugin we had access to the Enricher framework. And because we have actually bundled the Solr solution into a OSGI container inside the Andadu framework, we have access to other OSGI bundles, and so we have access to the enrichers, which are OSGI bundles.
Does the extension support date ranges?
The question is, does the extension support date ranges? Actually, yeah, we do. Any more questions?
Last question.
Okay, last question then.
How do you search PDF file and Word files?
Okay, the question was, how do we search PDF files and Word files? Actually, we use a tool called Apache Tika for that. What Apache Tika will do, it will open up Word files and it will take out all the relevant properties from that, but it will also take out all the free text, all the terms inside that document. So we get all the properties and all the terms, and then we're going to continue in the collection process and enrich it. We do the same for PDFs. So just remember, Apache Tika is very nice technology. Okay?
Thank you very much.
I want to thank everybody.